Hi, good morning. This is Trina here to discuss about the Bohr's model, the application of the Bohr's model and Sommerfeld model. So first, in my first lecture of the atomic structure, I have already told about the Rutherford model and how he did the experiment through the gold plate and the beam of light and which is moved through the gold plate, and he observed the different types of deflection, and from this deflection he drew the conclusion, and from this observation and the conclusion we got the several postulates. But it has some drawbacks. Again, we have, that means the Niels Bohr modified the Rutherford model, and today we learn the different application of the Bohr's model and also the Sommerfeld model. And in my personal details, I have given my mobile number and my email ID. So if you have any doubt, you can communicate with me. And the most important part, that is my course page. So here I have uploaded inter-study material, the different types of probable questions, semester questions, and solve problems. So I hope that already you have joined in my course. So once you join with the code DMBC, then you can access inter-study materials. So the course chemistry, the subject code CH101 for odd semester, CH201 for even semester. And the streams are CSE IT Civil Mechanical for even semester, Electrical EC BME for odd semester. Credits 3, contact hours 35. Weekly I will take 3 lectures. And to understand the concept of chemistry, you require to have the 12 standard knowledge. And about the course objective, the students will learn the several concepts of chemistry. So in the outcome, the students will be able to describe the fundamental properties of atoms and molecules and atomic structure. So in the lecture plan, it is the entire lecture plan is given. So you will be able to understand that the which topics will be covered in which day. So I have started the module 1, atomic structure. So already we have covered the first lecture, that is the Rutherford model. So its drawbacks and the Bohr's model. So you have seen that how Rutherford did the experiment with the alpha particle, the beam of radiation, and how it is passing through the gold plate and how it is deflected. So from the observation, we have seen that most of the particle passes through, very few deflected. So he concluded that a small part of the atoms is occupied by nucleus, that is the proton plus electron. But he was unable to explain the stability of the atom. So it was the drawback. And Niels Bohr told about the different orbit. Okay, so we have already discussed the Bohr's model postulates. So today we learn the application of Bohr's model, hydrogen spectrum, Sommerfeld model. So in the Bohr's model, what you have learned, can anybody tell? Anybody can remember what you have learned? Yes, this is the Niels Bohr model. So here you got the different orbit, like n is equal to 1, n is equal to 2, n is equal to 3. So each orbit has specific energy level. So when electrons move in a particular orbit, the energy level remain same. But when it moves in like higher energy level, outer orbit, it is the higher energy level, it is far from nucleus, it absorbs energy. And when it moves from higher to lower energy level, it is the inner orbit, then it releases energy. Okay, in this way, he explained and we learned the all postulates. Now, we will see that what are the application, how we can apply the Bohr model here. So the Bohr model of hydrogen, Bohr used the concept of quantization of energy and laws of classical physics. He gave many mathematical expressions like radius of orbit, velocity, and energy of electrons. So what we can calculate? We can calculate radius of orbit, the velocity, and energy of electron. So this expression satisfactorily explain the spectrum of hydrogen. Let's calculate all this expression to explain the spectrum of hydrogen. Okay, so first one is the radius of nth orbit. So according to Bohr's model, the attraction force between electron and nucleus is balanced by centrifugal force of electron, which is due to motion of electron and tend to take electron away from nucleus. So let's take that atomic number of atom Z. Next is charge of electron is E. So charge of nucleus, what it will be? It will be ZE. So radius of nth orbit will be Rn. So now we get the electrostatic force of attraction, that is Z square by Rn square. The centripetal force will be mv square by Rn. Now since the both forces balanced each other, so from equation 1 and 2, we get Z square by Rn square is equal to mv square by Rn square. Or we get b square is equal to Z square by Rn m. So from Bohr postulate, we get mv Rn is equal to nh by 2r. Okay, so you can remember that what is V, what is R, what is M, it is already noted, given here. So from the Bohr structure we get it, or m square V square Rn square is equal to n square h square by 4 pi square. H is the Planck's constant. Okay. So putting the value of V square from the equation 3. So we got in the equation 3, that is the V square, value of the V square. We get the expression that is m square into ZE square by Rn m into Rn square is equal to n square h square divided by 4 pi square. Okay, so ultimately we are getting Rn is equal to n square h square divided by 4 pi square mjd square. So now you know that h is the Planck's constant, and what is the value? That is the 6.62 into 10 to the power minus 27 R per second. Pi, you know, that is 3.142, 22 by 7. M, you know, that is the 9.109 into 10 to the power minus 28 gram. And E, that is 4.803 into 10 to the power minus 10 SU. So our final expression is h square by 4 pi square m square is equal to 0.529 Armstrong. So these things we have to putting the value of constants in 4. Okay, so equation 4, what is the equation 4? This one is the equation 4. So if we put the value in this equation, we get the final expression. That is very important. So you remember this expression, that is a very important expression. You can calculate through this expression. That is Rn is equal to n squared by z into 0.529 Armstrong. Okay, now since the atomic number of hydrogen is 1, so the radius of Init orbit of hydrogen will be, so just put in place of Rn, you just put 1. Okay, that is why we are getting here R1 is equal to n square. N square will be 1. 1 into 1. Okay. Z will be 1. Now 0.529 Armstrong. Since the value of Z is constant for an atom, Rn proportional to N2, so radius increases with increasing the value of N. If the value of N is constant, then Rn proportional to 1 by Z. Hence, radius of particular orbit decreases with increasing the atomic number. So you have learned a big thing, that if you take just you have taken here only 1, you can take like R2. Okay, you can take R2, you can take R3, then you will, that is your task, that first you take for the first orbit, that will be R1, that will be, first you calculate for R1, then you calculate for R2, then you calculate for R3. Okay, then you can get that how it will proportional to or not with the 1 by Z. How it is coming, you will get it. So you can get the conclusion that radius of a particular orbit decreases with increasing the atomic number. Clear? So the atomic number is fixed for individual atom. Okay, so 1 for the hydrogen. So if you put here like 2, so N2 will be equal to N square. N square means 2 square by Z, that is 1. Or if you take like say Rn, N is equal to 3, then it will become R3 is equal to N square, that is 3 square by 9 divided by 1, in this way. So you can calculate the radius. Next calculation is the velocity of electron in Bohr's orbit. calculation of the velocity of electron in Bohr orbit. So here we know that Jd square by Rn square is equal to mv square Rn. We got it before. So since the Rn is equal to n square h square by m Jd square 4 pi square, hence v square is equal to this one, or we can get this one. V is equal to Z e square 2 pi divided by NH. So now putting all constants, you know the value of all constants already got in the equation 5, you will get the value of V. So V is equal to Z by M into 2.188 into 10 to the power 8 centimeter per second. And you know very well that for hydrogen, Z is equal to 1. So for hydrogen, you can calculate the velocity. That is, if you take Z is equal to 1, so the velocity will be equal to 2.188 into Z 10 to the power 8. So you calculate in your home. Okay, so this is the task that for you take n is equal to 1, you take n is equal to 2 in this way, just you calculate for hydrogen. Next, the energy in electron in nth orbit. So basically I need to tell you one thing, that you remember the final expression. Okay, the final expression, this one is the final expression, that is the velocity, this final expression you remember. Okay. Next is energy of electron in nth orbit. Okay, how we can calculate energy? So En is equal to minus Jd square by R plus 1 by 2 mv square. Since you know that mv square is equal to Jd square by n, hence we can write En is equal to this expression. And we are getting En is equal to minus 12 Jd square by Rn. So we know that the Rn has the expression that is n square h square divided by m Z e square 4 pi square. So En will be equal to, if we put this one in the expression, we get En is equal to 1 by 2 Jd square into m Jd square 4 pi square divided by n square h square. Okay, now since you know the value of 2 pi square m square by h square is constant, if we put all the values given above, so we get 13.6 eV per atom. So ultimately, what we get, the final expression, the final expression we get, this is the final expression, you remember well, that is the final expression. Now if we put the value of Z and N, we can calculate the energy. So for hydrogen, Z is equal to 1, so En will be calculated by minus 1 by n square into 13.6 eV by per atom. Okay, now if you put n is equal to 1 for the first orbit, you can calculate the energy. So what you have learned to calculate? You have learned to calculate 3 parts. Number 1, you have calculated what you have calculated, radius of nth orbit, and you can calculate for hydrogen radius of nth orbit. Number 2, you can calculate the velocity of electron. Number 3, you can calculate energy of electron. Okay, so these 3 things you can calculate with the help of Bohr's model. Spectrum of hydrogen atom. Bohr atomic model states that the spectrum series arises when an electron jumps from an initial stationary orbit with principal quantum number n to the final orbit with principal quantum number n final. I for initial, this I for initial, and this F for final. Hence, the energy changes associated with these orbits are emitted as photon of frequency mu. Okay, so we can calculate the difference of the energy level, that is del E is equal to h nu, that is equal to EI minus EF. EI is the energy level of the initial orbit, EF is the final energy level of the final orbit. So since we know that E is equal to half minus half Z E square Rn square, and Rn is equal to n square h square by m Z square 4 pi square, we can calculate EI minus EF for both the orbit. You will calculate for first orbit, initial orbit where it was, then you will calculate for the final orbit where it is now. Then you can calculate the difference of the energy level. That means how much it will energy release or how much energy it will absorb. And we can draw the spectrum of the hydrogen. Okay, so you understood. Now the Sommerfeld atomic model. So in 1911, Sommerfeld began to research the atomic model of Niels Bohr, which was seen as the most accurate description of the atom at that time. The model postulated that electrons were located in circular orbits which had different energy level around the nucleus. So, I am showing you the video, you can understand better. In order to explain observed fine structure of spectral, Sommerfeld introduced two main modifications in Bohr's theory. So here you got the nucleus and electron is moving in not the circular path, it is in the elliptical path. So the velocity of electron moving an elliptical orbit varies at different parts of the orbit. This causes relativistic variation in the mass of moving electron. And now if we draw the line, and what will be the value of this angle from the electron to the nucleus? So this value is called azimuthal angle, this angle value. Now you will learn some important equations. To deal with these two variables, two quantum numbers are introduced. The principal quantum number first, n of Bohr's theory, which determines the energy of electrons. A new quantum number called orbital or azimuthal, quantum number L, which has been introduced to characterize the angular momentum in an orbit. It is to determine orbital angular momentum of the electron. So its value vary from 0 to n minus 1. This orbital quantum number L is useful in finding the possible elliptical orbits. The possible elliptical orbits are such that we can calculate by this equation, where the A and B are semi-major and semi-minor axis respectively of the elliptics. So if say n is equal to 1, when n is equal to 1, then L will be equal to 0. Only one orbit or one subcell is there. Okay, so A is equal to B. From the equation, you will get it. So it is the circular A subcell. This is the A subcell. So when n is equal to 1, it will be A is equal to B, and we get the A subcell. Similarly, for the second energy level, if we take n is equal to 2, there are two permissible subcells for the electron. For n is equal to 2, L can take two values, 0 and 1. So when n is equal to 2 and L is equal to 0, you write that B by A is equal to 0 plus 1 by 2. We get half. So B is equal to A by 2. So for n is equal to 2, we are getting 2p2s. This subcell corresponds to L is equal to 0. Okay. When n is equal to 2, so L is equal to 1 and L is equal to 1. So we are getting B by A is equal to 1 or B is equal to A. So n is equal to 2. Here you are getting 2p2s. This subcell corresponds to L is equal to 1, is circular in shape and is designated as 2p. So here you can see that designated as 2p. Here you can see the figure, that 2p. Now if say n is equal to 3. So L has three values, 1, 0, 1, 2. It is three permissible subcell for the electrons. When n is equal to 3, L is equal to 0. From the equation we get B by A is equal to 0 plus 1 by 3 is equal to 1 by 3, or B is equal to A by 3. When n is equal to 3, L is equal to 1. So we get B by A is equal to 2 by 3, or B is equal to 2A by 3. Okay, so here you can see the structure 3D, 3P, 3S. The subcells corresponding to L is equal to 0, 1 and 2 are designated as 3S, 3P and 3D respectively. The circular cell is designated as 3D and the other two are elliptical in shape. So here you can see that 3S, 3P and 3D. So here you can see that which one is the, this one is the elliptical shape, another is the circular shape. It is common practice to assign letters to L values as below. So if orbital quantum number L, if orbital quantum number is L, so we get that the electron state S. If it is 1, we get the electron state P. If orbital quantum L is 2, electron state is D. If L is 3, electron state will be F. If L is 4, electron state will be G. So it will be easier to understand, to remember. So the electron in the L is equal to 0, 1, 2, 3 states are said to be in the SPDF states. Okay, so I hope that you have understood the Sommerfeld atomic model. So if I summarize that what you have learned today, you have learned lots of things basically. you have learned that the application of the Bohr's theory. You have learned to calculate the radius, the velocity of the electron, and also the energy. And you have also learned the Sommerfeld atomic model, and you have understood, you have got the visually, you have seen visually, and you have learned, that means different orbitals. You have seen this one, that orbital quantum number, if as per the orbital quantum number, how the electron state depends. You have seen this one. So I will ask now few questions. So let's check what you have learned. So calculate the radius of third orbit for hydrogen. Okay, so calculate the radius of third orbit for hydrogen. Or I can say the calculate of radius of the first orbit for hydrogen. So can you remember what was the equation of the calculation of radius? Yes, you can remember? Okay, don't worry. Okay, I'm showing you that what is the main equation you have to remember. So this is the main equation. It is a very important equation, this one. Okay. So Rn is equal to n square by z into 0.529 Armstrong. So n will be 3 Rn, that means it will be R3 if you take for the third orbit, and n will be that means 3 square. Okay, it will be, so what it will be basically, I am showing you. So it will be R3 is equal to n square, that means 3 square, okay, divided by 1 into 0.529 Armstrong. Okay, so you can calculate. It is very easy. Only you remember this equation, you put the value and you will get the result. So in this way, not only for radius, you can calculate for the velocity, calculation of the velocity for hydrogen. You can also, it is also shown here that how we can calculate the velocity of hydrogen, and also you can calculate the energy of electron. So you can answer all these questions. Next is describe the Sommerfeld model. So you will describe the Sommerfeld model and all the quantum numbers, and I will elaborate the quantum numbers in my next lecture. So I am ending my session for today, and thanks for watching. Thank you everyone.